Hi, my name is Jonathan Peppers, and here we are at .NET Conf Focus on Maui. And here today, I'm going to talk about some of the performance improvements that we made in .NET Maui by the time that it released, um, as compared to what you may have seen in Xamarin Forms. Uh, so this is based on a big blog post that I did that kind of it really talked about every single change we made, and this is kind of like the highlights. Um, so be sure to check out the blog post if you really want to know some more detail of what I may not have mentioned here. This is kind of a shorter snippet. So, um, but anyway, we're also going to talk about like general concepts of how to get better performance in your own projects. Some examples is like always be measuring. Um, measure before and after, measure each release. We'll talk about some of that, what we did. Um, I'll also show how to profile your own .NET MAUI applications, which is also very useful when you're actually trying to get your app to be faster. And I'll, of course, give specific examples of performance improvements we made and also talk about some like experimental or advanced settings you could try out if you're really trying to get just a little more performance in your app. So let's get into it. So where did we start? So I actually work on the Android team, like the .NET workload for Android. Uh, but there was kind of a Microsoft, they call it a V team or a vertical team, where they take a bunch of people and, hey, we're trying to improve this thing, and we all work together. So we all came together to work on performance. We had some people from the .NET team, of course, Android team, the Maui team. And so here's where we started. So in Maui Preview 13, the metric that was interesting is if you look at the Xamarin Android app here. So this app is not using Maui or Forms. It's just a regular Android app, and it got faster between Xamarin Android to the .NET New Android template here. And what that told us that just using .NET 6 in general is faster than what we saw with Xamarin. Like there were improvements in the runtime, there were improvements in the BCL. All of those changes moving from back then it was just mono and moving to actually .NET. We saw some good improvements there. And then we just saw that if going from a forms template, it was somewhere between two of the forms templates is where the Maui template lies. So the blank template was quicker than the Maui template, but the shell forms template was slower than the Maui template. But we thought, obviously there's some work to do in Maui, the layer, um, to try to get everything matching here is what our goal was. And the .NET Podcast app, this is the last one, is it took about 1.3 seconds to start up. And so that one was an example of what a customer app would be. And that was also our big focus is like, we want to make sure that everyone's apps would start quicker. So here's where we ended up. This was also on a Pixel 5 device. But that podcast app, instead of 1.3 seconds, it's about 814 milliseconds in the version of Maui that shipped. And we plan to get that even faster in .NET 7. And yeah, we feel like this is a good place. And we'll talk a little bit about Shell. I mentioned it briefly, but that's a navigation pattern that's in Maui, and it's in the template. And it's kind of the recommended thing to use. And so we'll talk about a little bit more about what that is, later on. So let's talk about measuring over time, right? The .NET Fundamentals team, they helped us like set up tracking for Maui apps. So they had a lab with a device plugged in, and they would get a build of Maui so many times a day, and build an app, run it, record how long it took to start, and how large the app was. And that was extraordinarily useful for us to like see, like, are we making progress? Here's a good example when something happened, right? So this graph is on a Pixel 4a. That's what they had in the lab. But you could see here, we made a change to the Maui template, switched over to the shell. And there's a feature that we use on Android called AOT compilation. And we use profiled AOT, which means only some of the app is AOT'd to improve startup of your app, right? So when the template changed, drastically changed what code ran on startup. And so it went up, and then we updated the profile and it went back down. But of course, we had more work to do. It wasn't as low as before. So, but this was during, it got better near the end, but this was just a good example of we could see exactly when a change went in, what happened, and then the next change went in and how it improved. So here's another graph. This is that one was the template, and this is the .NET Podcast app. And this is a longer period of time, but this is really what we were going for, like sustained improvements throughout time, making sure that we're on track. And of course, this graph can be noisy, and so it's hard. Sometimes it's harder to see exactly, oh, it went down by 5 milliseconds. Is it really better, or but that's where the app size graph is extremely accurate in that it's a flat line most of the time, unless there is a change that affects the app size. So we don't have to go through all these, but here's an example where it went up when we updated the Android X libraries that Maui uses. And so Google added more code. That's just something that happens every year or all the time throughout the year. And we also had an issue in there. This section where we marked Xamarin Kotlin standard lim as trimmable. That was actually an accident where we found there was one assembly that we had a wrong setting on. Another thing that was very noticeable here, we mentioned Newtonsoft.json. There's nothing wrong with that library in itself, but this app uses Blazor WebView, and Blazor WebView uses system text JSON. So we had an app with 2 JSON libraries in it, right? So you're paying for that size twice. So we updated that app to not use Newtonsoft JSON, and we got a very nice size reduction in the app. So that's something that's worth checking out if you have something like that in your app. So let's talk about profiling. So this is another part of measuring is just don't go blindly changing code in your app if you haven't measured something that says that, hey, this part of your code is slow, right? You could be changing something that doesn't even matter, right? So in .NET, we use .NET Trace, and there's a companion for .NET Trace because .NET Trace, it connects to a .NET process on your system. DS Router lets it talk to a remote app running on a phone, which it's a little tricky to set all this up. You're probably going to have a couple terminal windows open while you're doing this, but we're working on making this easier. Hopefully one day you can press one button and do it. We'll see if we hope that happens soon, but basically you run a couple commands that sets up your remote device. You launch DS Router, and then you launch .NET Trace, and then you launch your app, and then a file pops out at the end. I like to use the SpeedScope format, just because it's very visual, and maybe if you've never done something like this before, I think it's probably an easier starting point. Otherwise, you can get NetTrace files that you can open in PerfView or Visual Studio, but you might start with the SpeedScope if you've not done this before. And check out this link if for more detailed instructions than these. This is just kind of like an overview, but so that file that comes out at the end, you can go to this website. It's just a web app, and it just kind of opens the file locally. It doesn't upload it anywhere, but it has this nice graphical view of all the methods in your app and approximately how long it took. And so this is an example. I have an app named Foo, Maui app, and here's an initialize component method and how long it took. And you've probably seen those methods. That's where it's loading your XAML. And if you drill into the method, you get a view like this, and it's this might be a lot to look at, but what you're looking for is a method that takes time, and then you drill down in there, and as soon as you see a bar that like jumps down a lot, not a great example here, but maybe this onChild added method. Of course, that's in Maui, but you might go look at that method and just see, is there anything, that we're doing there that, hey, we could do something faster instead, right? And a lot of this is experience. Like, you got to have some intuition of what you're looking at. Like, looking at this, I don't exactly see anything to go investigate. But yeah, this is just an example. Yeah, so let's talk about some actual work we did in Maui. These are not necessarily all the biggest wins. I just kind of handpicked some that seemed interesting, but hopefully they will be. So single file assembly stores. So this is a feature that we also got in Xamarin. So if you have the latest version of Xamarin, this feature's there too. But previously, all of your .NET assemblies just were files in your app. And the thing that's interesting about Android is when you install an app, it actually stays in the APK, like compressed like a zip file on the phone. So you can't just like open files directly out of your app. You may have noticed that you can't use build action content and do a file open, like that doesn't work. And so what we do is we use a system call called mmap, and we had to load all these individually. And so we did some work at build time. We pack all these files into smaller files. So instead of, let's say you're a Maui app and you had, I don't know, could be 30 assemblies, 50 assemblies, depending on how big your app is or what's in it. Instead of loading those 50 files individually, we end up loading like one or two, right? So there's an assemblies blob that's all the stuff, and then there's one per each architecture, because there's a couple assemblies that are different per architecture. But so this is a good change because Maui apps tend to have a lot of assemblies, and we didn't want to pay that cost. So here's another really good improvement that's in Maui. A while back, so Xamarin Forms, I wrote this experimental little library for Xamarin Forms that we would use an Android library called Glide for loading images. And it's actually like the library that Google has been recommending for a while for loading images on Android. Because if you use the Android APIs directly, it's really easy to get wrong and use up, I don't know, the image APIs in Android are just hard to use. And if you go wrong, your app runs out of memory and crashes. So using this library was a good idea. So we kind of pulled that over to Maui, and it uses this library for loading images by default. So that was a good improvement. You really notice a difference, like if you have images with like URLs to the image on the web, like you'll see a big difference comparing Forms and Maui. But just general image loading should be better as well. Here's another interesting example. So I saw in the SpeedScope file we saw before, I saw some examples where we were spending time loading Android layouts in Maui Startup. And so I wrote a little benchmark like, hey, how long does this really take? And I took a layout that had like 3 views on it. It had hardly anything. And you could see a clear difference between loading the layout with XML, I did an example in C Sharp, and then I did an example in Java. And the difference is there's no interop, like going from C Sharp over to Java. And we could see a difference. And it made sense because there's time spent for Android to parse the XML, right? And then as it parses it, has a string for each thing in the document. And then it uses Java reflection to like create everything that's in the document. Well, if you just, instead of doing all that, it just had straight code and ran the code in Java or C Sharp, it's obviously that's going to be faster. So we used like an approach where I ported all the code to Java, and then we kind of called in once from C Sharp, and that gave us like the best performance that we could see. And we did this for, I think, about 4 layouts that were called in Maui Startup. There might be a few more depending on what features you're using, but we're going to aim to try to get rid of any of these that we see while profiling. Here's another good example. So I talked briefly about the cost of calling from C Sharp into Java, and this is kind of illustrates that. So let's say you have 2 Java methods, set foo and set bar, and the C Sharp binding code for that looks like these other two, this second 2 methods here. And basically, it's going to p invoke right here. So like a DLL import that calls into like C, and then it finally gets into Java, right? So what's faster than doing this twice is if you made a Java method called set foo and bar, and you pass in foo and bar, right? You would end up crossing the barrier like once instead of twice. And so we tried to use this technique a lot of places in Maui, where if they're showing up in a profile like, oh, look, we're calling into Java 7 times here, we'll make a method with 7 parameters and call in once, right? We did this in a lot of places. I think one place it might even be like 17 parameters, and we saw a big difference in making changes like this. So I would only look into this if you see it in your app and you really find a hot path. But Maui, that's kind of a place where we're wanting to do it so that developers don't have to do stuff like this. Okay, so Maui image. This is a good one. So if you've used Maui image, it's really cool. You can throw an SVG file in your app, and it'll resize it for you. And you don't have to know all those weird sizes for Android, sizes for iOS. Yeah, and so there is some caveats here. Is that if you don't put a base size, that it looks in the SVG and it just uses the base size that's in the SVG. There's SVG files are they're an XML file, and there's a canvas size or something, I think. And so a problem we found is the template, the .NET bot that's on the Maui template, it was set to a huge size. And which it's just whatever design tool was used to create that bot, that's just the number that the designer had. So it makes sense that, whoops, that happens, but you just make sure that you put a base size on your images is just what it comes down to. We put that in the template, and we saw both startup improvement and app size improvement. Same thing with if you're using a JPEG or a PNG. Make sure you use a base size. Like the way to check this is to check your app. Like if it's an Android APK, you can just unzip it and just look at the images inside, right? And see, like, do these sizes make sense? Yeah. Here are some just like quick tips. So we'll just kind of go through these. So system link, you've probably heard of before. Like link is kind of slow for performance. My tip is just avoid it where you can. Like if this can be a for each loop, just make it a for each loop. But there's like you can make a link expression that is slow, right? But sometimes like things like order by or first to default are completely fine. It just Just depends on what your code is doing. And if it shows up in the profile. So all these make sure, like, is this method showing up that it's slow in the profile? So another one are culture aware string comparisons. So this would be if you did like string starts with and you didn't pass string comparison ordinal or ordinal ignore case. This one is kind of expensive on the first one, right? So if you can eliminate all of them from your app, you can get a startup time improvement. So what we did for this is we kind of added a code analysis rule in Maui so that we can't add one. Like you'll get a build error if you add one on accident. So same thing with dictionaries. You can pass string comparison ordinal or string compare ordinal. It depends on what method it is, which one you use. Just similarly, avoid regex options compiled in Xamarin Android and Mono back in the day. This option didn't do anything. And so you might move to .NET 6 and find out now this option actually works, right? It spends extra time to create the regex so that you can call the regex a lot and it be fast. But if it's a regex you use once, it's actually worse. Right? So this is actually noticeable on mobile. So I would recommend not using this setting. .NET 7, they have this awesome new feature where they create a source generator for your regular expressions. So I'd look at that in the future if you really have to use this in your app, but just something to avoid for now. And lastly, datetime now. This one, just don't use now when UTC now works, right? Like when you call now, people don't realize like on the first call, it loads a time zone database and does a bunch of math to figure out like what is the current time. So yeah, just keep that in mind if you really need that or not. Okay, so these are options that maybe eventually we'll be able to turn on by default, some of these, but we'll look at each one of these. So R8 is, what this is, so we have a trimmer in .NET, and an R8 is a trimmer for Java. And we can't turn this on by default yet because it's possible that it'll link out too much, and then at runtime you'll get like an error that's like, oh, this method is missing, but you need it, right? So the way to turn this on is you set Android link tool equal R8 for your release builds, and if something does go wrong, it's usually pretty easy to fix. Is that you add a ProGuard file, which some history is that's a rule format for an older shrinker called ProGuard. R8 is the new one. And you can preserve whatever method that was removed on accident. But it's worth going through this, I think, if you're trying to get your app small. This is probably going to be one of the bigger wins you can do on Android. So another idea, so let's say that you don't care so much about how large your app is, but you want your app to start as fast as possible. So this might be something like maybe it's a line of business app that people are installing internally in a business. You know, you may want to turn this on. This is a setting that would AOT everything in your app instead of just the startup path. And so then every method in the whole app is going to start quicker, run quicker the first time. And so to do this, you just have to turn off profile AOT in this example. So this isn't even really experimental. It's just not the default setting, right? So feel free in doing this one. So I think that's all I have for today. We're going to be working on performance in .NET 7 future releases. And so this is not really the end of what we're doing. So, you know, hopefully this was useful for you and maybe some of these ideas you can apply in your own apps. Thanks.